Hello, Math 120 students. I am going to give you some extra examples from section 5.5. The whole idea is that if you have things that are multiplied together, whether it's 2 things or 3 things or 5 things, A times B and the product is 0, then either A has to equal 0 or B has to equal 0. That only works when the product is 0. So we have to have our equations in standard form. Standard form means we have them in this form: ax squared plus bx plus c, and then it equals 0. If it's not equal to 0, it doesn't work. Okay, so once they're in this form, we can factor this left side. So it would look something like this after it's factored. So you have these two things multiplied together. You have the factor of x plus 1 and the factor of x minus 5. If when we multiply them we get 0, then either the x plus 1 has to equal 0 or the x minus 5 has to equal 0, or both of them. So we're left with these two little equations right here to solve. Solving this one, you get x equals -1. Solving this one, we get x equals 5. So you can see both of these, x equal -1 or x equals 5, are solutions. So you can check it. If you put in -1, both places for x, it looks like this. You'd have -1 plus 1, -1 minus 5. -1 plus 1 is 0, -1 minus 5 is -6, multiply that together and you get 0. Looking at your x equals 5 for your solution. Again, if I plug in 5 for both places of x, I'll have 5 plus 1, or 6. 5 minus 5 is 0. 6 times 0, 0. So, again, we need to be in standard form, our equations. So that means set equal to 0. Once we're there, we factor the side that has the polynomial. Then each of the factors gets set equal to 0. We solve and we find our solutions. All right, so I'm going to do some extra examples for you right now. All right, so let's take a look. If I have x times x plus 6 equals 0. It's already factored, so I just take each of my factors and set them equal to 0. So I have that factor, just plain old x, equals 0. And then I have the x plus 6 factor, set that equal to 0. Now x equals 0, there's nothing even that I have to do there. That one's done. This one, I'm going to subtract 6 from both sides, and I have -6. So I have two solutions, 0 and -6. Example 2. Let's say I have the equation x squared plus 9x minus 36 equals 0. We are in standard form. It's set equal to 0. I'm going to factor the left-hand side. This is an easy factoring one because the leading coefficient is 1. So I'm going to set up my two binomials, and I'm going to put it x and x. I'm looking for factors of -36 that add up to 9. We know they're the opposite. And factors of 36, I'm going to take 12 and 3. X plus 12, x minus 3. So now I'm factored. X plus 12 times x minus 3 is going to equal 0. If the product is 0, then either x plus 12 equals 0 or x minus 3 equals 0. Solve each of those little equations that you have left. So subtracting the 12, x is -12. Adding the 3, x is 3. So those are my two solutions right there. -12 and 3. So the solution set is negative 12 and 3. Both of those values, if I plug it back in the original equation right here, you can check it yourself, you should get 0. So if I take negative 12, put it here and here, simplify, I should get 0. If I take 3, put it here and here, simplify, I should get 0. All right, let's look at another example. Let's see if I turn this paper over, not to waste paper. Yeah, it's going to show through. All right, let's try it. Okay. Example 3. How about if I have 9x squared minus 2x equals 0? Already in standard form, set equal to 0. I'm going to factor this. What is the number one rule of factoring? Of course, we do not talk about factoring. But after that, we're going to take out the greatest common factor. And I have a greatest common factor, x. So x comes out, leaving me with 9x minus 2. So each of these factors I'm going to set equal to 0. This one is just plain old x, or the 9x minus 2 equals 0. The x equals 0, nothing to do there. I've already got one solution. It is 0. This one, I'm going to add the 2. 9x equals 2. And then I'm going to divide out my 9. Gives me 2/9. So that means I have, again, two solutions. The 0 from that factor and 2/9 from that factor. So my solution set, I have 0 and 2/9. Both of those are solutions to that equation. Okay, let's look at another example. Example 4. 5x squared minus 3x equals 8. Now it is not set equal to 0. That one was already set equal to 0. That's what must be true. We have to have it set equal to 0. Okay, so that is the first thing we're going to do. So we're going to take this 8, put it to the other side by subtracting it. 5x squared minus 3x minus 8 equals 0. Getting a shadow. Let me adjust my light. See if that works better. A little bit. All right, so now we're going to factor. We're going to factor this guy right here. Okay, now this one, not quite so easy because the leading coefficient is not 1, but it's prime. So however you like to factor it, you're going to get it factored. I'm going to put my 5x and my x, 1 and 5, that's prime, that's the only choices. Now the 8, remember I have choices of 4 and 2 or 8 and 1. I'm going to say it's 8 and 1 because remember the inner and the outer have to give me a -3. This is negative, so they have to be opposite signs. This is going to be a -8. This is going to be a +5. Gives me a -3. Once you got that factored, however you want to do it, you do not have to do it trial and error. You can do it by your grouping method. So just double check it and make sure it's correct. Once you have that, we take each factor. 5x minus 8 equals 0. X plus 1 equals 0. And 5x equals 8. Dividing out the 5, I have 8/5. This one, all I have to do is subtract the 1. X is -1. So there's my two solutions, 8/5 and -1. Both of those are solutions. So the solution set, 8/5 and -1. If you plug them into your original equation, it should check. Okay, let's look at this example. X cubed equals -8x squared minus 15x. Again, not in standard form. It needs to be set equal to 0 in descending order. So my x cubed is over here, so I'm going to go ahead and bring these two to the left side. I'm going to add the 8x squared, and I'm going to add the 15x. So it looks like this. X cubed plus 8x squared, added that, plus 15x, added that, and then on the right, those will both be gone and it'll equal 0. Now we're going to factor this. Looking for your greatest common factor first and taking it out. So x cubed plus 8x squared plus 15x. Greatest common factor, x. Take it out. Now, what's left here in the parentheses? Does that factor? We're going to factor that next. Factors of 15 that add up to 8. 5 and 3. Now we take each of our factors and set them equal to 0. So the x, now I have 3 things. A times B times C. 3 things multiplied together that give me 0. So all 3 of these factors get set equal to 0. The x plus 5, and the x plus 3. All 3 of those could be 0. 1 or 2 or all 3. So here, we don't have to do anything. That one has already given us a solution. X is 0. Here, I'm going to subtract the 5. So x is -5. Here, I'm going to subtract the 3. X is -3. So now I have 3 solutions, 0, -5, and -3. 3 solutions for this equation here. 0, -5, or -3. All 3 of those are solutions. Okay, so make sure that it is set equal to 0 in standard form, and then factor it, and all of the factors get set equal to 0, and they're going to give you a solution. Once you set all the factors equal to 0, you solve where needed, and those are your solutions. All right, let's look at one little application problem, and then we'll be done. So I had that written out earlier, but so let's say I have, let me see if I can zoom in on this problem. I'll just rewrite it. All right, let's say we have a function that is a function of time. T is representing time in seconds. And this function represents the height of an object that is dropped from a building that is 144 feet high. And it is modeled by this equation, okay? So T is the time in seconds after the object is dropped. And then this F of T is representing the height of the object after T seconds. So for example, if I put a 1 in here, that's going to tell me how high the bucket is after 1 second. 1 second after dropping. Or object, whatever it is. In the problem, it's a bucket. So if I do F of 1, negative 16, 1 squared plus 144. This is going to be negative 16 plus 144. So what is our height? So 144 minus 16. 128. So F of 1 means after 1 second, the height of the object is 128 feet. So again, it was dropped from 144 feet tall building, from the top of a 144-foot building. Okay, so that's how that works. This is the function that defines the height. F of T is the height, right? Remember, that's just another way of writing Y or H, right? I could have written H for height equals negative 16 T squared plus 144. Okay. So I can ask the question. Here's my question. When will the bucket hit the ground or the object? When, that's a funny looking H. When will the object hit the ground? What's the height when it hits the ground? The height when it hits the ground is 0, right? When it hits the ground, the height is 0. So right in here, this whole thing, not in for T, but this whole thing, we're looking for T. When will the object hit the ground? So we're looking for T when the height is 0. So we're going to write out 0 equals negative 16 T squared plus 144. And we're going to solve that. We're going to solve that equation. So what are we going to do first? I'm going to factor out a 16 because I believe that 144 is divisible by 16. So I'm going to go over to my calculator and check it. And it is 9. So there is a greatest common factor here of 16. Now the leading term is the leading term is negative. So remember, when the leading term was negative, we would factor out a negative. So let's do that. Negative 16. So that leaves me with T squared minus 9. Oh, let me put that on the other side. I don't want to confuse anybody. Right? I factored out a negative 16, so that leaves me t squared. This is going to become the opposite, and it's 9. 16 times 9 is 144. So now I'm going to continue factoring. That's the difference of 2 squares. So I have negative 16 t plus 3 t minus 3. So I have 3 factors where the product is 0. Now the first factor, the negative 16, does not contain a variable. It's just negative 16. So that cannot equal 0. So I'm not even going to worry about that factor. It does not have a variable. So I'm only going to take the factors that have variables, the t plus 3 and the t minus 3. So this one is going to give me a negative 3. This one is going to give me a positive 3. Now the negative 3 does not make sense in this problem. We can't have negative 3 seconds. Remember, t is the time in seconds after we drop the object off of the building. So we're just going to get rid of that one, and t equaling 3 is our only solution. So in 3 seconds, the object will hit the ground. There you go. All right. Let me know if you have any questions.